Here's another interesting and important question that we have. This is a tube containing an ideal gas which is revolving about this axis with an angular velocity equal to omega. The pressure at the fixed end is given to be P1 and the pressure at the free end is given to be P2. We need to find out the relation between P1 and P2. So for solving this question, the first thing you should realize is that the pressure is different throughout the length because different amount of pressures is needed to perform the circular motion of individual columns of air that is inside. So let us draw the diagram first. This is the tube. Let us consider a column of gas over here of thickness dx at distance x from the axis. Let the pressure over here at this end be P plus dP and the pressure at this end be P. This is a very standard way, and you have to do this kind of thing in many questions, that you assume. Previously when a rod used to rotate like this, we had assumed the tension over here to be T plus dt and the tension here to be T. So in many such questions you have to apply this method. So we assume the pressure here to be P and here to be P plus dP, that is the pressure on the right hand side is a bit greater than the pressure on the left hand side. So we can write the equation for the circular motion of this mass, that is dP into area of cross section, that is the net force acting on this element in this direction, that is equal to m omega square x, that is equal to mass into acceleration, that is centripetal acceleration. This is the centripetal force. This is revolving with omega. Now we need to find out what dm is. For that, let us use the equation PV is equal to nRT. Since this is an ideal gas, therefore we can apply PV is equal to nRT on this part of this column of the gas. Therefore the pressure can be taken to be P. It is almost P plus dP is also almost P. Therefore P into volume, that is A into dx, is equal to number of moles. Number of moles can be written to be dm, that is small mass, upon the molecular weight m into r into T. Therefore dm can be written to be equal to P into A upon into m upon RT into dx, that is dm is equal to PAM upon RT into dx. We substitute this value here to get dP into A is equal to PAM dx upon RT into omega square x. Now from here A gets cancelled and we get dP upon P is equal to m upon m omega square upon RT into omega square into x dx. On integrating this, we need to find out the increase in pressure till we come to this point. There is a dP increase in pressure till we come to here. To find out the pressure at we need to find out the pressure at this point. Therefore we integrate this from 0 to L, that is the length of the rod. To get this we integrate from, the pressure initially was P1, the pressure finally is P2, and here we integrate from 0 to L. Since at x is equal to 0, the pressure is given to be equal to P1, and at x is equal to L, the pressure is given to be equal to P2. On solving this we get ln of P2 upon P1 is equal to m omega square upon RT into L square by 2. Therefore we can write P2 is equal to P1 into e की power m omega square L square upon 2 RT. So this is a final answer for the relation between P1 and P2. So from this question we learnt an important method as to how to assume pressures on the two sides and integrate to get any deviation in pressure.